Hello, Integrated Math 1. Welcome to lesson 2.4.2b. So we're still looking at the area and perimeter of triangles and rectangles on the coordinate plane. We're just on the second day of that mess. We've already been doing pretty well with this. We're determining the perimeter and area of rectangles on the coordinate plane, determining perimeter and area of triangles on the coordinate plane. Just a quick reminder, if you need it, we did say last time that the perimeter of a rectangle, so these are rectangles, perimeter of a rectangle was twice the length plus twice the width. We also said that the area we could think of as length times width, or the way I preferred it is to say that the area is base times height. And of course, we're doing this for triangles as well. So when we're talking about triangles, the perimeter for a triangle, just add up all the sides, A, B, and C, just be like, yay, we're adding you together. And for the area of a triangle, it was 1/2 of the base times the height. So these are old formulas. I know you already know them, but it's just been a while. It's good to remind ourselves. Ooh, and actually, I'm going to erase these because I have a little more. Hang on. You're also going to push us a bit further today. We're going to use transformations to discover efficient strategies to determine the perimeter and area of rectangles and triangles. We're going to see if we shift our shapes around on the graph a little bit, will that make it a little easier to work with? So again, you've used a distance formula, slope formula to classify your geometric figures on the coordinate plane. Now we're using distance formula and slope formula, mostly distance formula, to determine the perimeter and area of rectangles and triangles on the coordinate plane. We're using that distance formula to help us find our base or our height or our length or our width so that we can plug into our formulas in order to figure out what our perimeters and areas are. So with this in mind, we're on page M2-279. You have this lovely, lovely little triangle, and it has vertices. X is at 2, 5, Y is at 10, 9, and Z is at 6, 1. If you want to write those on the picture, you can. You certainly don't have to, but it's kind of nice. I like having it written on the picture, but that's just me. What I would like you to do with this first, I would like you to determine the perimeter of triangle XYZ. You may need to use some distance formula to help you out with that. And if necessary, round your answer to the nearest hundredth. Go ahead, hit pause to work this out. Hit play when you're ready to check your work. So I hope you have a calculator handy. Grab mine. I know I'm about to need it. So I'm going to grab my lovely calculator here. Oh, there we go. I'm ready. So I have my calculator, and the points disappeared. So real quick, X was at, just so I have them useful, X was at 2, 5. You have them on your page still. I don't. They disappeared. Y was at 10, 9. And Z was at 6, 1. I'm only 6 foot, not quite 6, 1, but I'm close. So let's go ahead and use distance formula. You should have used it 3 times, right? If you want to find the perimeter, you got to add up all the sides. So I need to know what the sides are. So from X to Y, we'll subtract our X's, 2 minus 5, subtract our Y's, 5 minus 9. Of course, 2 minus 10 is -8, and 5 minus 9 is -4. If we square those, we get 64 and 16, which together is 80. And I rounded to the nearest hundredth. It's about 8.94. So there's side XY. We do want to find the other side, so let's find side YZ. So I'm going to use Y and Z, so I'll subtract my X's, 10 minus 4, subtract my Y's, 9 minus 1. Of course, 10 minus 6, I said 4, didn't I? 10 minus 6 is 4. I was getting ahead of myself. 9 minus 1 is 8. If we square those, wow, Miss Scott. That should be an 8. It's an 8. If you square them, you get 16 and 64. Add them together, you get square root of 80, which is, again, is about 8.94. Ooh, we have a nice isosceles triangle, don't we? 2 equal sides. What? We got 2 congruent sides. We have a nice isosceles triangle. Let's find our third side, XZ, right? We need to find XZ. So I'll subtract my X coordinates, 2 minus 6, subtract my Y coordinates, 5 minus 1. 2 minus 6 is negative 4. 5 minus 1 is 4. Square those, they're both 16. And if you 16 plus 16 is the square root of 32. So it looks like it's about 5.66. And of course, we are finding the perimeter. So I need to add all of these together. Plus C, plus C, plus C. I'm going to add them all together. And when I add them all together, I get about 23.55. Now, I will warn you, it might be a little different. Like if you use your calculator, 8.94 plus 8.94 plus 5.66. You actually got 23.54. That's because we rounded early. So I like to not round early. I like to make sure I leave things in here, and then I'll let my calculator do all the work and round it at the end. So again, it doesn't matter whether you round early or whether you wait till you round to the end. It can change your answer just a little bit, so watch out for that. Now, we found the perimeter. And yes, we had to use distance formula like 3 times, but that's okay. We found that this was the square root of 80, square root of 80, and that last one on the bottom was like the square root of 32. So I'm just going to use that real quick. I would like us to find the area of this triangle, but there's a problem here, right? I need to find the base and the height. Now, you can pick whatever side for the base that you want to pick. That's up to you. That's totally fine. It's your choice. I'm going to pick XZ, and I suggest you do the same because the problem is finding that height. Please remember, and you might want to write this down somewhere, height is perpendicular to the base. All right? Height is always perpendicular to the base. It should always make a right angle with the base. So there's a problem here, right? Because, I mean, just even looking at it, forget working out slopes or anything, just looking at this. XZ does not look like it's perpendicular to YZ. It does not look like it's perpendicular to XY, and those two definitely don't look like that's enough for a right angle there. So let's go through a few steps. We're going to write point V that's going to represent where our height hits the base. So here's my base, and I'm going to put a point V on here somewhere that represents where my height is. So remember, height has to go from the top, and it's got to drop straight down perpendicular to the base. So let's look at this. If I wanted to be perpendicular, which I do, we said last time, or actually I guess a couple times ago, we said perpendicular means the slopes are opposite reciprocals. Okay, so if my slopes are opposite reciprocals, let's find the slope of the base, and that should tell me the slope for my height. Okay, it's going to tell me the slope for my height. So let's find the slope of my base. And if I look at my base, which we said is going to be XZ, that means I had to go down 4, so that's a negative 4, and then over 4. So it looks like the slope of XZ, my rise over run, is negative 4 over 4. Now, of course, that does simplify down because negative 4 divided by 4 is a negative 1. That means that the slope of my height, which we're going to call YZ, so we're going to say that our height, because it has to go from Y to wherever this Z point is down here. So we're going to say our height, sorry for the bad handwriting. Oh my gosh. I'll fix it. That's why I love erasers. So the height, we're going to call that YZ. And so we're going to say that the slope of YZ is the opposite reciprocal. Well, this is 1. You can even put it over 1. So they need to be opposite. So if this is negative, my new slope should be positive. And if this is 1 over 1, then my new slope, I guess, will also be 1 over 1. Yeah. So my new slope is also going to be 1. All right. Are you watching? Are you watching? So cool. You watching? So I'm going to start at Y because this is the top of my triangle now. If this is my base, this is the top of my triangle. And I'm just going to go I would go, I guess I could go up 1 over 1. I'm going to go up 1 over 1. And remember how you can do this over and over again? You can do it over and over again, going the other way as well. Oh my gosh. Oh, my pen. What is it doing? Oh my gosh. Busted out the highlighter instead of the eraser. Oh my gosh. Okay. So I'm going to go up 1 over 1. And of course I can go backwards. So 1, 1, 1, 1, 1, 1, 1, 1. Oh, check it out. We found where my height should hit my base, haven't we? This height, this height right here, oh, should make a right angle with my base. And you can call that point V if you like. We'll label it V. It does say to determine the coordinates of V, so I guess we should be good, and we should write down what the coordinates are. It looks like V is at 4, 3. And there's a reason why we need those coordinates. All right. So here's the deal. Sorry. I have a bunch of extra stuff here you don't need. It's a harder way of doing the same problem, but we're not doing that. All right. So here's V. Yay. We know that V is at 4, 3. Now, a few things. I want to find the area, which means I need the height. You told me that V was at 4, 3. We already know that Y is at 10, 9. Oh, is there a formula you could use to figure out what that height is? Because I think there is. Go ahead, hit pause, use that formula to find your height, and then hit play when you're ready to check your work. You ready? Did you use the distance formula? I know I did. So I'm going to use the distance formula. I'm going to subtract my x's, 10 minus 4. I'm going to subtract my y's, 9 minus 3. And this worked out pretty well. 10 minus 4 is 6. 9 minus 3 is also 6. That's nice. 6 squared and 6 squared. So those are both 36. If I add those together, I get 72. And so it's about, square root of 72 is about 8.49. Hey. We have a height. We found the height, right? This is our height. And earlier, we found out the length of our base, didn't we? Didn't we say that we found the length of the base? Wasn't that like the square root of 36 or something like that? Seems like that's what we found out what it was. Yeah, you have the base. You have the height. Find the area of the triangle. Hit pause, find the area of the triangle, hit play when you're ready to check your work. All right. We found the base earlier, like when we were doing perimeter. We were still doing perimeter, but we found out the base was about the square root of 32. So we're like, hey, that's the square root of 32, our lovely base here, root 32, or about 5.66. We found our height earlier. Ooh. And when we found the height earlier, we found out that the height was the square root of 72, which was about 8.49. You know what to do. The area of a triangle, you know the area of a triangle, 1/2 base times height. You got all the pieces. So I'm going to put them in. 1/2 square root of 32 times the square root of 72. Turns out if you're careful using this in your calculator, you get exactly 24. Remember the trick from earlier? I did skip a few steps here. Remember the trick from earlier, though? I'm sorry, my lights are out. I need my lights back on because my solar-powered calculator doesn't work so well without light. So remember our trick from earlier that you can multiply this stuff in the square root first and then do the square root? So I did 32 times 72. And that means I got the square root of 2,304. And then I did the square root. And it turned out it was perfect. I got 48. And if you cut 48 in half, you get 24. So you just found the area of the triangle was 24. I can fit 24 square units of stuff inside my triangle. Nice. So we learned, we're realizing some interesting things. You've done some translations, also known as rigid motions, before. And when we translate something, we're just sliding it over, and it preserves size and shape, right? If I'm just doing a translation, I'm just sliding things over. I'm not changing the size. I'm not changing the shape. The pre-image and the image are congruent. Because in a translation, all vertices are rigidly moved from one location to another location. If I move one point down 5, I move the other point down 5. So we haven't been encountering some issues with our rectangles, right? And actually even some triangles. You know, the lengths of the sides of a rectangle RSTU will be preserved if we translate it, if the rectangle is translated. That means the perimeter of the rectangle is translated as well. So I would like you to just take a moment, because we have some really big numbers here. Oh my gosh, we have some really big numbers here. And do you remember how much I love 0? Yeah, I love that origin. I love 0. It's really easy to use things with 0. I would like you to translate this rectangle, RSTU. I would like you to translate it, slide it over, and you can write on the graph. That's what it's for in your book on page M2-275. I would like to translate it over so that R is sitting on the origin. Just remember, whatever you do to R, you have to do to S, you have to do to T, you have to do to E, you have to do to all of them, okay? So go ahead and scooch it over. We'll call the new guy, instead of R, we'll call it R prime, new S will be S prime, new T will be T prime, and new U will be U prime. Go ahead and hit pause and translate that rectangle right on over there, and then hit play when you're ready to check your work. How'd you do? So we said we wanted R to be on the origin. So that means I need to go down 1, 2, 3, 4, 5 down and 1, 2, 3 over. So it looks like I have to go down 5. Except when I can't spell, just kidding. I'm working on it. So it looks like we need to go down 5 and left 3. So there's my new R. So I'm going to call it R prime. But that means I have to do it to all of them. I have to move S down 5 and left 3. So 1, 2, 3, 4, 5, 1, 2, 3. There's S prime. I need to do it to T, down 5, 1, 2, 3, 4, 5, left 3, 1, 2, 3. So there's T prime. And I have to move U, 1, 2, 3, 4, 5. And then left 3, 1, 2, 3, and there we go. There is U prime. And now I can connect them. Oh, my rectangles are beautiful. In fact, here, let's get rid of my janky, I'm going to get rid of my janky writing here. I have nice, pretty typed writing, okay? There we go. So R prime, S prime. Oh, they're all out of order. R prime, S prime, T prime, U prime. So why did we do this? Well, I don't need distance formula, right? Why do we do this? Because look how easy it is. If this is 0, how easy is it to figure out the length of that side? How easy is it to figure out the length of this side? So now that you've done that and you've just made things so much easier, can you find the perimeter and area of the rectangle now that you've moved it? Go ahead, hit pause to work this out, hit play when you're ready to check your work. So one of the things I did want to do is I want to make sure I know how long these sides are before I do perimeter and area. So it looks like if that's 300 and that's 600, halfway in between them, I'm pretty sure that's 450. That would be halfway in between 300 and 600. Pretty sure that means that each square is like 75. So if I do some math in my head, right, 4 squares gets me to 300. If I do a little math, forget in my head. If I do 300 divided by 4, I have a calculator. So 300 divided by 4, yeah, each square is 75. So that means this side is 1, 2, 3, so that's 75. So that means if that's 3 of them, so 3 times 75, how much is that? 225. So it looks like this side is 225 units long. So this is way easier than trying to use distance formula, right? It's just a little less work. I know that's 450 units long. That's 225 units long. So for perimeter, I'm back in the dark, twice the length plus twice the width. Great. 2 times 450 plus 2 times 225. Thank you, Mr. Calculator, because if I double that, that's 900. If I double that, that's 450. Add them together, my perimeter is 1350. Of course, the area is just the base times the height. So fine, that means that we're going to do 450 times 225. Thank you for calculators. I got 101,250. I got a big number, which should be the same area as the original. So when it asks, what do you notice? That's what I'm noticing. Pretty sure this should be the exact same area as the original rectangle. So the perimeter and area of r prime, s prime, t prime, u prime is equal to the perimeter and area of r, s, t, u. Let's do one more problem. I would also like to find the perimeter and area of this lovely triangle, but I'm looking at it and I hate the way it is right now. I would like you to transform triangle ABC on the coordinate plane. I'd like you to shift it over and explain why you made that shift. Go ahead and hit pause. See if you can put it in a place that'll make it easier to use the numbers, and then hit play when you're ready to check your work. So I was looking at this, and I was looking at these vertices, and I was like, oh my gosh, I can't even figure out what the vertices are. Like, it's weird. So I thought, what if I shifted it down to put it on the x-axis? And then I also thought, well, if I shift it over, so I'm going to go down 1 unit. Everybody's going to go down 1 unit, so it sits on my x-axis. That'll make things easier. But I'm also going to shift it to the right such that that point B ends up on the y-axis. So I did that. So I vertically translated the triangle down 2 units to get it onto my base. And then I also translate it horizontally to the right 5.5 units so that B is on the axis, because look how nice these points are now. Now, these are really nice points. Much easier to work with than what I had before. So now that you have these lovely nice points, I would like you to find the perimeter and area of triangle A prime, B prime, C prime, and if necessary, round your answer to the nearest hundredth. Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. All right. So you know what? I'm lazy. So I actually started with side AC because I was like, that's easy to use. So side AC, I just counted. So I was like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm like, oh, look, side AC, A prime, C prime is 10 units. Woo. I then did finally have to break down and use distance formula. I couldn't do A prime, B prime, and I couldn't do B prime, C prime without them. So I did have to, I was like, oh, I got to write down the point. So that's 8, 0. And A is now at -2, 0. And B prime up here is at, what is that? What is that? 4, 6, 8, 10, 11. I guess that's at 0, 11. Okay, then. So I used some distance formula. So I did AB first. And I realized there were a few ways of doing this. I skipped a few steps, my bad. There are a few ways of doing this, but I noticed I went over 2 units, right? This is a little Pythagorean theorem. So I did 2 squared, and then it looks like I went up 11. See how there's these zeros here? Check it out. 2, 11. So I did 2 squared and 11 squared. Oh, I didn't have to do all the subtraction cred and worry about negatives. That's magical. So 2 squared is 4, 11 squared is 121. Together that's 125, and the square root of that is about 11.18. It did say to the nearest hundredth, so 2 digits behind the decimal, guys. I then did something similar for B, and I realized, like, yeah, I could subtract, but I got zeros. Why am I stressing about over subtraction? 0 minus 8 is 8. 11 minus 0 is 11. Oh my gosh, I'm just going to do 8 squared plus 11 squared. So 64 plus 121 is 185. And again, thank you, Mr. Calculator. Square root is about 13.60. And yes, I did put the 0 on there because I couldn't push it up, but I needed a second digit. If I'm rounding the nearest hundredth, I need 2 digits behind the decimal. And we're ready for perimeter, right? Just add these up. I'm just going to add them up. And I got about 34.78. Yay. Now, area. Let's talk area. So I've got my perimeter. That's great. Ooh. I need the area. For area, I need base times height. Well, the base is easy. I can count, right? My base is 10, baby. But look how we moved B over. How easy is that to find the height? Now check that out. How much is that? 2, 4, 6, 8. It's 11. Oh my gosh, because look where B is. It's at 0, 11. My height is 11, guys. Oh my gosh. So my base is 10. My base is 10. My height is 11. I'm going to multiply them and divide by 2. That gets me about 55 units. Rock on. So this is a nice little trick. Scoot your little shapes over, whether it's a rectangle or a triangle. You can scoot them over a bit and set them on an easier place on your graph. Just makes it easier to get some numbers off of this thing, right? Right. Makes it a lot easier to find your bases and heights and sides and things. So as always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, please feel free to come talk to me. I'm here for you. I want to help you out. And I'll see you guys later. Bye.